Hi, my name is Fatemeh Ahmadi, postdoc researcher at the University of Western Australia, Perth. First of all, thanks for giving me this opportunity to be participated in the scientific competition. And Today I'm here to introduce a novel nitrogen slow-release fertilizer that is related to the energy, water, and the environment. Nitrogen as a nitrate form is the most important macronutrient in the plant system. Every year, a large number of nitrogen required by plants is added to the soil in the form of nitrate fertilizers. However, the unprincipled use of nitrate fertilizers has caused a lot of environmental serious problems and especially affected human health. The pollution of water and soil resources and the reduction of the efficiency of using nitrate fertilizers in the soil caused the farmers to use nitrate chemical fertilizers more and more. And it was actually in order to increase the productivity of the crops, but it's greatly increased the problems in the environment, soil and water and environmental pollution, and affect the human health. So what should we do? What's the problem and how we can solve the problem? About the nitrogen fertilizers. As we discussed, nitrogen is essential for plants and we cannot dismiss it. And the other problem is environmental pollution. So how we can make a balance between two problems, two main ideas. Okay, now there are a lot of, in the few decades, there are a lot of types of fertilizers. Slow release fertilizers or controlled nitrogen release has been considered in a lot of countries. Oral fertilizer with sulfur coating or formaldehyde or polymer coated urea are among the most important types of slow release fertilizers that are available today. But the slow-release fertilizers that are available so far has a lot of different limitations, and this makes them unusable in every situation and for every plant, because each plant has its own nutritional needs. In addition, despite the importance that medicinal plants have on human health, so far no remedy has been thought about these plants. So, for the first time at the University of Western Australia, we set out to develop a slow-release nitrogen fertilizer that not only does not have the limitations of current slow-release fertilizers, but also focus primarily on high beneficial medicinal plant Echinacea purpura. Paying attention to two important issues was our main goal. The medicinal plant that have the researcher for the first time is Echinacea purpura plant with more than 25 valuable medicinal plants. We focused on a new nitrogen slurries fertilizer with a new novel uh, ura polymer coating agent that is natural products, low cost, able to be used in society, environmental friendly, completely environmental friendly, and biodegradable soon. The methanol plant as we discussed, is so important on has the different benefits on human health. We focused on two main points: what's the echinacea N requirement, nitrogen requirement, and how long does the plant growth take, so we can make a balance between nitrogen release rate during the time and plant growth period. To solve this problem, uh, we use a substance as a coating agent which is based on the sucrose. So that is has five main items: natural, low cost, able to be society environmental friendly. In this context, attention was paid to the plant's need for enough nitrogen during the growth cycle, so that not only enough nitrogen is provided for the plant, but environmental damage is also reduced to a minimum. This work was done under precise and controlled experimental conditions at the same time as plant analysis. All coating steps were carried out according to the standard methods, and each step was checked using the high-tech equipment at the University of Western Australia for the first time. The mechanism of a nitrogen slow-release fertilizer from the plant was investigated in three different types of fertilizers, and each step was examined through photograph to ensure the correctness of the test steps. Final product as shown in the slide, that is white tablets of nitrogen storage fertilizer with the chemical pro- properties. The product that we produced and tested of Echinacea medicinal plant resulted in many remarkable achievements. We tested all steps according to the experimental chemical experiments and high-tech instruments. At the result, when we uh, checked all the experiments and uh, harvested the plants growing based on the nitrogen slow release fertilizer, and when we compare the result with the plant grow under the natural conditions without the slow release fertilizer or control, we successfully received a very good results, like increasing the caffeic acid derivatives in the plant Echinacea purpura was more than three times in the plants, in the medicinal plants growing based on a novel nitrogen slow-release fertilizer, increasing essential oil components as well, alkyl amides, and root system development that is very, very, very critical and important for uh, plant growth and nutrient accessibility for plant. Increasing phenolic and phenolphthalein components in the plant, antioxidant activities in the plants all were increased two or three times more in the plants grown based on the novel nitrogen slow-release fertilizers. We also tested this new nitrogen slow-release fertilizer on the other as medicinal plants with relatively similar growth period to Echinacea purpura, such as thyme, rosamarza, and Montana. The application of this fertilizer had a positive effect on the growth of these plants, and other phytochemical tests for these plants are on the way. Significant successful publications were also achieved in this research. We successfully published 35 articles in high-ranked journals, nine articles exactly about the Echinacea purpura and novel nitrogen slow-release fertilizer with Elsevier, Nature, Springer, and all of these. And I successfully won the Iranian Nobel Prize for scientific and high-tech research on the medicinal plants, especially on Echinacea purpura, grown based on the novel nitrogen slow-release fertilizer. We tried to both increase the medicinal plant compounds, we significantly decrease the environmental pollutions of nitrate and nitrogen into the environment, soil and water pollution. And I have a patent about the nitrogen slurries fertilizer in Iran. As shown in this slide, we published an article about the root system development and morphological properties of Echinacea purpura grown on hydroponic cultivation system and using novel nitrogen slow release fertilizer for the first time. And we compared the results with the control and the plants grown under natural conditions without nitrogen slow release fertilizer. On the other slide, we focused on the cell mechanism, molecular studies, and ATPase activity, antioxidants activity of Echinacea purpura grown based on the novel nitrogen slowly fertilizer for the first time, and we compared the results with natural conditions. It was really interesting, very, very interesting results. Amazing. And in the other slide, it's about the essential oil of Echinacea purpura and other methanol plants, phytochemical compounds, alkaloids, and so on. And we suggested that we can increase the methanol and phytochemical compounds of this methanol plant and other methanol plant like this growing period using novel nitrogen and slow release fertilizers that are all published in the high ranked scientific journals. And this slide is about my Nobel Iranian Nobel Prize 2022 that was focused on my research about the methanol plants and reduce the environmental pollutions and caused from fertilizers, nitrogen fertilizers. Thank you so much for your time and attention. Hope to be successful. Thank you. Bye.